Welcome to day 8 of this unit. It's our review. We have a test on the next day. If you go ahead and look at the study guide that I've posted online, it will actually give you a detail of what the problems are going to be on. So this is not an all-inclusive review. I'm just going through a few problems here, 4 examples to be exact, and kicking you some practice problems as well. So I'm going to go ahead and start this problem by graphing out A, B, C, and X, Y, Z. While that's not required for this problem because you could just do distance formula a lot, I'm going to go ahead and do it with graphing. Now I've got these graphed out. Really the benefit of graphing is that a couple of the sides I can compare without having to graph. For instance, I'm going to need to show that AC matches XZ. And for both of those, I don't really need to use distance formula here. I can just actually count the blocks from 1 up to 7, so the AC is 6 units long, and for XZ it's going from 6 on my X value out to 12, so it's also 6 units long. Simple as counting the blocks there. So I know that AC does equal XZ like it's supposed to. They both equal 6. This will be part of what I'm showing to see if they're congruent or not. Now I'm going to calculate the distances for AB and XY. When I'm doing that, I could use distance formula, or I can simply make a right triangle out of it for AB and say, alright, this is going to be 4 squared plus 2 squared equals C squared. So I'll just kind of do that work up in the top here. This is calculating AB, so it's 16 plus 4 equals C squared. So C is equal to the root of 20. 16 plus 4 was 20. I took the square root. You might also simplify that down to 2 root 5, albeit that's not really going to be required for this. So I'm going to go back onto my graph here and call this root 20. I erased a little too much there. But I also simplified that to 2 root 5. Now I'm going to calculate XY, doing the same thing. Again, you could use distance formula here, but Pythagorean theorem works pretty well. And I actually see that this is going to actually work out the same. 2 squared plus 4 squared equals xy squared. It's actually going to work out the exact same as what I had on the previous one. So I'm actually just going to go ahead and call it 2 root 5. And those match. So I'm going to go ahead and make that note that xy was congruent to AB, which was 2 root 5. And now where I'm going to go is go ahead and calculate BC and make sure it matches YZ. So when I calculate BC, I've got 4 units and 4 units. So this will be 4 squared plus 4 squared equals C squared. So that's 16 plus 16, so that's going to be 32. Not 36, 32. Square root that, and I'll have the square root of 32, but that does simplify down. 16 will go into it twice, and square root of 16 is 4. So 4 root 2 is how long BC is. So I'm going to go ahead and jot that in real quick. And now I'm going to do the same thing for YZ. Make a right triangle here. 4 squared plus 4 squared. Well, I can actually see right now that it's going to set up the same as what the other one did. This is going to be 4 root 2 as well. So now I'm going to be able to say that BC equaled YZ, which is 4 root 2. Now I can say that yes, the triangles are congruent by side, side, side. Alright, and that wraps that up. Like an extension of this problem, let's say instead the problem had asked, is triangle ABC congruent to triangle YZX? And the answer here would have been no. That even though you did have matching measures, the 6 match, the 2 root 5 match, the 4 root 2 match, they don't match correctly for this statement. So like AB was 2 root 5, meanwhile YZ was 4 root 2. So the answer to this problem would have been no, they are not congruent. Because the corresponding parts didn't match. Alright, that wraps up this problem. Let's go and move to the next one. On example 2, we're going to be determining the distance between the parallel lines, y equals 1/3 x plus 5 and y equals 1/3 x minus 5. I'm going to go and get those graphed using the slope, rise 1, run 3, and also starting at my y-intercept, 0, 5 on this one, and here my y-intercept will be 0, -5, but I'll still be rising 1, running 3. Now that I've got those lines graphed out, when I'm figuring the distance between two lines, I'm actually going to pick a random point on one of them. And if you remember, I always like to make that a y-intercept. So I'm actually going to pick the point 0, 5 in this case. Alright, now I need to actually make a perpendicular between the two lines. So since my slope up here was positive 1/3, my perpendicular slope is going to be negative reciprocal. I'm going to flip the fraction, so it's going to be 3/1. I'm also going to negate it, so it's going to be -3. If ever the slope is negative, you'll turn it positive whenever you make that negative reciprocal. That was, by the way, -3/1. Now I'm going to go from the point I picked and go down 3/1. So it's going to make this right here. And lo and behold, this is really nice because it did land on a nice square even point that I can actually calculate the distance of. Now I'm going to go ahead and draw in that perpendicular. Don't really need to. All I really needed here was the point that it is 3, -4. And now I just need to figure out the distance between 0, 5 and 3, -4. I could do what I did on the last problem and make a right triangle here and calculate the distance that way, or I can use distance formula. Since I didn't show distance formula on the last one, I'm actually going to show it here. And here's my distance formula. If you've forgotten it, you need to take note of it. This is something that you'll need throughout Math 2 and Math 3. And now I'm going to be considering this to be x1, 0, y1, 5, x2, 3, y2, -4, just the way I'm doing it. You could do it the other way around and it works out just fine. But I'll have it setting up as 0 minus 3 squared, the square root of 0 minus 3 squared, plus 5 minus -4 squared. And now I'll simplify all this down, that this will be -3 being squared, plus 5 minus -4 is 5 plus 4, so that's 9 being squared. So now I'm going to have the square root of 9 plus 81, which is the square root of 90. Now you want to look for any perfect squares that can divide out of that so you can simplify this down. And in fact, the obvious one is that 9 will go into 90 10 times, and I can square root 9 down to 3, so 3 root 10. There's no more perfect squares that will divide out of the 10. I'm actually done with the problem right there. It's 3 root 10 units away. Now, if those first couple problems seemed a little bit heavy for you, fortunately there are some easier problems on the test, so we're going to talk about those now. For instance, on this problem, you're going to find the measures of angles 1, 2, and 3. Actually, where I start is either angle 2 or angle 3. It's probably easiest to find angle 2 for most of you. If you notice this right angle mark, you'll know that the whole angle is 90 degrees. So using angle addition postulate, I know that the measure of angle 2 plus 52 is 90. Using angle addition postulate, I can take the 52 off of 90, which is probably what you did to begin with. You didn't even bother writing it out. That's fine. And this is equal to 38 degrees for angle 2. And I'll make a little note on my diagram of what I found for it, but that's one of my 3 answers. For angle 3, I would actually look at the entire triangle, the big triangle, that I have 47 plus 90 degrees plus angle 3 adding to 180. Using triangle angle sum theorem. So I'll be taking the 90 and 47, combining that to 137, and taking that away from 180. So the measure of angle 3, I would now know, is equal to 43 degrees. There's another answer. Angle 1, you could do it one of a few ways. I could add the 47 and 38 and angle 1 to 180. That's probably where most of you would go with it. And subtract the other 2 angles from 180. That's fine. Just to change things up a little bit, angle 1's an exterior angle, and 52 degrees and 43 degrees are its remote interior angles. So I actually know that the measure of angle 1 is equal to 52 plus 43. That it's equal to the sum of the remote interior angles. That was something that we covered in class. That's something that you need to know for the test tomorrow. It is very helpful. So that comes out to 95 degrees. Now obviously this figure was not drawn to scale, but they never are really. So keep that in mind. Don't hold me to, hey, this doesn't look like 43 degrees. It doesn't have to. All right, one last problem. All right, on this last problem, we're going to be finding x, y, and z. Since there's only one expression with y and only one expression with z, I'm actually going to start by finding the x's since there's two expressions involving x. Now you have to remember that these lines are parallel, and you got to remember the relationships for parallel lines. 6x and 2x plus 20 are interior angles because they're between our two parallel lines. Also, they are consecutive interior angles because they're on the same side of the transversal. And if you'll recall, you might need to study up, consecutive interior angles are supplementary, so they add to 180 degrees. So I can set it up like this, that 6x plus 2x plus 20 is equal to 180 degrees. Combining like terms, subtracting 20 from both sides, and dividing by 8, x equals 20. So I just determined x. Now that's going to be very helpful in finding the other stuff. For instance, what I would do is substitute that 20 in right here. 2 times 20 is 40, plus 20 is 60 degrees. I know that this is 60 degrees. And I know that these two angles would have to add to 180. They're a linear pair. So I would set up for z that 2z minus 3 plus 60 is equal to 180. And I would combine my like terms. I would subtract 57, and that's going to be 123. And I would divide by 2, and I get 61.5. A good point to make here, just because you get a decimal or fraction does not mean that you're wrong. I mean, I know that you might want to go back and double check your steps, but this is the correct answer here. As far as how to set up the last one, you got one of a few options. Perhaps the easiest is figuring out this angle. 6 times 20 would be 120 degrees. And knowing that 8y and 120 degrees would be vertical angles, so they're equal. So 8y equals 120. And all I got to do is just do 120 divided by 8, and I get 15 for y. And that finishes up our problem. There's x, y, and z. Not the only way that this could have been done. Maybe you could have even used corresponding angles here to set the 8y equal to the 2z minus 3. But we've gotten all three correct answers. Hopefully it made sense for you. If you got any questions, let me know before school, or you can email me even. I'll try to get back to you. Good luck on your test.